Osoko, thank you so much for coming. All right, so Amamani Trifati. Sorry if I'm not pronouncing it well. You say, what are the dimensions of kinetic energy? Okay, so good afternoon, everyone, for coming to today's live class. We are going to look at electrical energy. But before I go into that, I saw a question and she said I should find the dimension of kinetic energy. Okay, so let me just dive into that. If we ask to find the kinetic energy is the same thing as work because they are measured in joules, right? Okay, so kinetic energy is equals to what? Work done. Now, if you say what is work done is force times distance. Okay, if work done is force times distance, what is force? Force is mass times acceleration. Okay, then times distance. Now, what is mass? The unit of mass is kilogram multiplied by unit of acceleration is meter per second square multiplied by unit of distance is meters. Now, if you bring them together, we are going to have kilogram meter per second square times meter. Now, this meter has a power of 1 and 1. I'm going to bring them together to have kilogram meter 1 plus 1 per second square. Okay, then we now give rise to what? Kilogram meter square per second square. If you have this as the unit of energy, okay, what do we do now? We're going to get the dimension. The dimension is equals to, this is kilogram, unit for mass. I will say M, this is L, and this is what? T. So the dimension of kinetic energy, which is the same thing as work, becomes ml squared t minus 2. I hope that is okay. All right. Okay, I'm residing presently in Nigeria. I am in Nigeria right now. Amamani, I hope that solves your problem. Thank you so much for joining. I hope you understand that. So let's dive into what we have. Okay, the topic I want to discuss today is buying and selling of electrical energy. But I can't tell you how we buy and sell electrical energy without explaining what is electrical energy and the units of electrical energy and work and power. So I'm going to explain all that before we dive into the main topic, which is buying and selling of electrical energy. Augustine, Ifeanyi, thank you so much for joining. I really appreciate. Please double tap on your screen to give it a thumbs up. I believe you can see. Let me just arrange the, so you can see clearly. Now, electrical energy is given by quantity of charge multiplied by. All right. Now, if you go by that, I will say that electrical energy E is equal to quantity of charge multiplied by potential difference, which is what? V. Now, we still remember what is quantity of charge. Quantity of charge, if I go back to electric current is the rate of flow of charge along a conductor. That is the quantity of charge divided by the time. Now, since I am looking for the quantity of IV what? T, right? Now, this is the formula for electrical energy. We still have different formulas for electrical energy. I'm just going to state all of that for you so I can see it. Now, we have IVT or I square RT or V square over RT or PT. Now, electrical energy is not just only electrical energy. We can still call it electrical work, electrical heat. They are the same because they are measured in joules. So we can use either of them to solve problems involving electrical energy, electrical heat, and work done. Now, all these parameters, what does they stand for? So we have I as current, which is electric current, then V as potential difference. Okay, I have T, which is time. Then what again? I have R, resistance. Then I have P, which is what? Power. Okay. Now, these are the formulas that we're going to use to solve for electrical energy, electrical heat, electrical work done. Because I said it's electrical, that means we are looking, because the examiner is set to ask the question based on terms. So you should know that this formula will be for electrical energy, electrical heat. Okay? Right. They are all measured in joules. Electrical energy, electrical heat, and electrical what? Work. They are all measured in joules. And you're going to use this similar formula to solve, which is IVT or I square RT or V square over RT or PT, right? Where I stands for electric current, P is potential difference, T is time, R is resistance, and P is power. So I'm going to see questions that will help us to attempt on this concept. Sorry. Mr. Augustine, fine. Your network is bad. Thank you, Mr. Onyeka, for coming in. Please double tap on your screen to give it a thumbs up. I really appreciate it. Thank you so much for coming. All right. Let's look at this example. A current of 0.5 amperes flows through a resistor when connected to a 240 volt supply. How much energy is dissipated in 2 minutes? Let me do a recap. A current of 0.5 amperes flows through a resistor when connected to a 240 volt supply. How much energy is dissipated in 2 minutes? Now, for us to solve this question, the first thing we are going to do is to state our parameters clearly. Fit in what we have, then we get our answer. We have current to be given as 0.5 amperes. Then when connected to a 240 volts, the potential difference is 240 volts. Okay? How much energy? You're looking for E. Dissipated in 2 minutes. So time is 2 minutes. Now, don't forget that this time must be converted to seconds. It must be in seconds, right? So we are going to multiply by what? by 60 because 60 seconds makes 1 minute. Okay, so in 2 minutes we are going to have what? 2 times 60 to give us 120 seconds. Now if you go by that, we have all the formulas. Let's state all of them to know the one that will fit in. Electrical energy is equals to IVT or I square RT or V square over RT or PT. Now, looking at what we have the current I, so this can go. Let's see. We have potential difference V. This can go. This one has V, but it does not have what? Current. So we can't use this. Okay? This does not have current and potential difference, so we can't use this. Then we are comparing between these two. So we can see that we have current, we have potential difference. Even though this one has time, but it does not have potential difference. So this is what we are going to use to solve this particular question. Now, let's proceed. E is equals to IVT. Okay, what's my current? My current is 0.5 times potential difference is 240. Then I'll multiply by the time, which is giving us 120. Okay, so with the use of our calculator, we go 0.5 times 240 times 120. Okay, so I have 14,400 joules. We have 14,400 joules. So if you are asked to put your answer in standard form, you are just going to do from here, you go 1, 2, 3, 4. So that becomes 1.44 times 10 raised to power 4 what? Joules. Even though it's similar to this one is when I want to leave it in a standard form, but this is the same answer as what? As that. Do we understand? All right, let's go to another example. All right. Let's look at this question. That should be example 2. Lisa Copper, thank you so much for coming. I hope you enjoyed the class. Just stay tuned. All right, let's look at example 2. Of 2 amperes flows in a heating coil of resistance 50 ohms for 3 minutes 20 seconds. Determine the heat produced. Now, this particular question has different parameters from the previous one. So the first step you're going to take is to state our parameters. All right? So we are given a current I, which is 2 amperes. Okay? Then the resistance R, 50 ohms. And the time, we have 3 minutes 20 seconds. That means 3 minutes plus 20 seconds. Remember that we are going to convert this minutes to seconds before we add, because our time must be in seconds. Okay? Now, for us to convert this minutes to seconds, we are going to multiply by 60, because 60 seconds makes 1 minute. So I'm going to say T is equals to 3 times 60 plus what? 20. Okay? 3 times 60 is 180. 180 plus 20, that will give me what? 200 seconds. Sorry. So I don't even know where the thing ended. Maybe I have to start all over again to explain that. Okay. Now let me explain it again. So sorry, network is too bad. I said we are giving a current of 2 amperes, resistance of 50 ohms, then the time of 3 minutes 20 seconds. Okay, so what you need to do is to convert these 3 minutes to seconds. Then we add these seconds because your time must be in seconds. So we're going to say 3 times 60, and that is 180, plus this 20 seconds to give up what? 200 seconds, right? Now, stating what we have all these formulas, but this is the particular one that will fit in what we have. So we say H is equals to I square RT, okay? My I is given as 2. I put it here. My R is 50, and my time is what? 200. So remember to square your I, which is 2 squared will give me 4 times 50 times 200. So the answer is going to give me 40,000 joules. Is that okay? All right, let's look at one more example before we go to electrical power. Question we're going to look at is this: what is the total electrical energy consumed by an electric cooker rated 1000 watts for 5 hours? Now, in this question, we're looking for electrical energy, and we have just these two parameters, which are the power and the time. Okay, so we have power is 1000 watts, and time is 5 hours. What are we going to do? Now, from the formula, we have energy is equals to IVT, or I square RT, or V square over RT, or PT. Now, from what we have, the only thing we are going to use here is what? PT, because we have power and what? Time. Now, if you say that E is equals to PT, but there's one thing we must do. Look at this, our time. Time is given in hours, and I said our time must be in seconds. So what do? We are going to do our necessary conversions. Okay? Now, we are going to say that 60 minutes will give me what? 1 hour. Okay? Will give me 1 hour. Therefore, 5 hours will give me what? X. I can say cross multiply to get it in minutes. Okay? I'm still going to show you another shortcut. Now, if I multiply, I'm going to have X is equals to 300 minutes. Right? Okay. Then, for me to get it to seconds, I'm going to say X is equals to 300 times what? 60 to get it to seconds. So I will have 0.0018. So the answer becomes 1000. Answer becomes 18,000 seconds. That is a long form of it. Then I can give you a shortcut of converting it to seconds. You just say T is equals to 5 times 60 minutes times 60 seconds. Okay? If you multiply, let's use calculator so that we'll be sure. You have 60 times 60 times 5. We are going to have 18,000. So the answer is 18,000 seconds. So let's put in what we have. E is equals to power times time. My power is given as 1000 times time is given as 18,000. Okay? Now, by the time you multiply, I'm going to have 18 million. Okay? So you have 1800000. Okay? Joules. Joules, or we can decide to change it or put it in standard form by saying this is what? 1, 2, 3, 4, 5, 6, 7. So I would say 1.8 times 10 raised to the power of what? 7 joules. Do you understand? So this one has just power and time. And the first thing I'm going to do is to set our parameters, then convert this to seconds so that we can get our electrical energy. And look at the formulas we have. The one that will fit in is PT. So we put in PT and we'll do our conversion to get our time as 18,000 seconds. All right. So we multiply and the answer becomes 1.8 times 10 raised to the power 7 joules. Do we understand? All right. Please, if you are just joining or just double tap on the screen to give it a thumbs up. Thank you so much. So the next thing we are going to do now is we are going to look at electrical power. But we have other units of power. Now, 1 kilowatt is equals to 1 kW. Okay? So K means kilo and kilo means 1,000. So in case you are given, for example, 3 kW, okay, that means I'm going to remove the value of K by multiplying by 1,000. Then 1 megawatt. Mega is capital M, watts. Okay? Then it's equivalent to 1 million watts. Also, we have 1 horsepower. That is 1 HP. Is equivalent to 746 watts. Do we understand? All right, so let's derive the formula of electric power, sorry. Then we can now see how we can apply it to solve our problems. Now, electric power is equal to rate of work done. I will say this is electrical work done over time. Now, what is electrical work done? Electrical work done, which we have derived, is IVT over time, or I square RT over time, or V square over RT over time, or PT over time. Right? By the time this cancels all, time cancel time, we cancel this, we cancel this, we cancel this, we cancel this. So the formula for power becomes IV or I square R or V square over R or P, right? Where I is electric current, V is potential difference, R is resistance, and P is power. Hope you understand. All right, so electric power is equal to work done over time, and we have derived or we have solved problem on electric work done, and we have this as what? P as IVT over time, I square RT over time, V square T over R over time, then PT over time. So by the time we'll cancel the time, we are left with power is equal to IV, I square R, V square over R or P, right? So the only difference between power and electrical energy is when to multiply the power by time to get electrical what? Energy. Do we understand? And I already said that power is watts. and I've given you the sub other units of power, okay? So let's dive in and solve a few examples under electric power. Tracy Harrison, thank you so much for coming. Please just double tap on the screen to give it a thumbs up. Okay, let's solve examples on that. All right. Okay, let's go. I'll say example 1 under this. The resistance of a 240 volts, 60 watts electric filament bulb is dashed. Okay. So going by what we have, let's look at the question. The resistance of a 240 volts, 60 watts electric filament bulb is dashed. Now let's state our parameters. Our resistance is what we are actually looking for. The potential difference V is giving us 240 volts, and the power P is giving us 60 watts, right? Now, we are looking for resistance, and since we already had power, or we are giving power, so the first thing that will come to our mind is what are the formulas of power, okay? Let's just state all the formulas. We say that power is equals to IV or I square R or V square over R. Now, going by what we have, we don't have current in the question. So these two cannot go, okay? So we have potential difference and we're looking for resistance. So I'm going to use V square over R. So P is equals to V square over R. Okay, so what's my power? My power is 60 over 1 is equals to, my potential difference is 240 square over what? R. So the next thing I'm going to do is to say cross multiply. I say cross multiply. 60R, this times this, that is 60R, is equals to 240 square. Then I divide both sides by the coefficient of R, which is what I'm looking for. R. Okay. Coefficient of R, sorry, is 60. I have 60, then I cancel 60. So my R here is equals to, so let's divide. 240 square is equals to, let me solve it here. Because of space. I will say R is equal to 240 square. I'm going to have 57,600 divided by 60. So I'll divide by 60. So my R becomes 960 what? Ohms. 960 ohms. So this is the symbol for what? Ohms, and that's the units of resistance, okay? We have done resistance, series, and power in my previous video, so you can check it up in case you don't know how to do that. Right, so in this question, we are giving power, we are giving potential difference, and we have to find the resistance. So we are able to state our parameters and state all the formulas we have, and this is the particular one that will fit in what we have. Then we brought it out and make our subject, and we arrive at our answer to get the resistance. I hope you understand. All right, so let's look at example 2. This is example 2. All right, let's look at this second example. An equipment whose power is 1,500 watts and resistance 375 ohms will draw a current of dash. So going by what we have, let's first state our parameters by saying that power is equals to 1,500 watts. Then the resistance is given as 375 ohms. Now, what are we looking for? We are looking for current. Now, the first thing I'm going to do is to state all the formulas of power and see the one that fits into what we have. So we say P is equals to IV or I square R or V square over R. So which one will fit in what we have? We have power, we are looking for current, and we have resistance. So this will go and this cannot go, right? So going by that, we have that P is equals to I square R, right? Now P is equals to, what's my I? My I is current, and that's what I'm looking for. Okay, let me just state in what I have. My power is 1,500 is equals to, I am looking for current, 75. So what I'm going to do is to divide both sides by current of I square. You divide by 375. 375. This cancel, this will be left with I square is equals to, now we divide 1,500 divided by 375. Okay, we have what? We have 4. All right. Then for us to get the answer, we say I square is equals to 4. So I'll take the root of both sides. Okay? This cancel this to be left with what? I. And the root of 4 becomes 2 amperes. 2 amperes because the units of current is what? Amperes. Okay? All right, let me do a recap. An equipment whose power is 1,500 watts and resistance of 375 ohms will draw a current of dash. Now, since you're looking for the current, what you're going to do is tell and then put in what we have, look at the particular formula that will fit in, then we multiply and we substitute and get the unknown, which amounted to our current to be 2 watts, amperes. Do we understand? All right. All right. For us to solve this, we have an electric car, an electric iron is rated 500 watts, 200 volts. Calculate the current required to operate the iron. That is first question. Then the second one, the energy generated in 30 minutes. Okay, let me confirm. That is 30 minutes or 3 minutes. Okay, the energy generated in 30 minutes. Now, for us to solve it, the first thing we are going to do is to state our parameters. Then we are giving power to be 500 watts, potential difference to be 200 volts. Okay, so we have the T to be 30 minutes. So for us to solve, we are going to convert this 30 minutes to seconds by multiplying by 60. So T is 30 times 60. It's going to give me 1,800 100 seconds as my time. Then for me to get the current, the first thing I'm going to use is to find the power. Know that formula for power, the one that will fit in what I have is what? IV, okay? Then, what is P? P is 500 is equals to, I'm looking for current, that is I, times potential difference, that is 200. So what I'm going to do is to divide both sides by what? By 200, okay? All right, this cancel this, okay? So I have I is equals to 5/2, which is the same thing as 2.5, which is the same thing as 2.5. 5 divided by 2. Okay, so I'm going to have the current to be 2.5 amperes. Okay, so let's go to the next one. All right. The next question there is for us to get the heat generated in 30 minutes. And for us to get the heat, we can simply multiply the power obtained by what? By time. Now, we say the heat is equals to PT. Okay? What's my P? My P is given as 500. So I'll say 500 times. The time is given as 1,800. Okay? So we're going to multiply by saying 500 times 1,800. So I'm going to have 900,000 joules, right? If I want to put it in standard form, I'll go this way. 1, 2, 3, 4, 5, right? So this is 9 times 10 raised to the power of 5 joules. Do you understand? Okay. Let me do a recap. We are given an electric ion that is rated 500 watts, 200 volts. Calculate the current required to operate the ion. Then, second one, the heat generated in 30 minutes. How do we solve this problem? It's by saying that the power is given as 500 watts, PD, which is potential difference, given as 200 volts, T is time, which is given in 30 minutes. And we must convert the minutes to seconds by multiplying by 60 to give us 1,800 seconds. Then from our formula, P is equals to current times PD, and that is what we are looking for. We're looking for current. So we substitute our value by saying this is 500 is equals to current times 200 given. So we make I the subject to obtain our answer to be 2.5 amperes. Then going to the second one, the heat generated in 30 minutes. So we already have our power to be 500, okay, multiplied by time, which is 1,800, and we arrive our answer to be 900,000. Then we can change it to standard form by saying that this is 9 times 10 raised to 5 watts joules. Is that okay? Because units of energy or heat or work is measured in joules. Is that okay? All right. All right. Now let's go into what we have today, which is buying and selling of electrical energy. right, let's go to buying and selling of electrical energy. Okay, now electrical energy consumption is sold in kilowatt hour. Most of us now use prepaid meter in homes, and most times when you check the kind of the energy you have, you're going to see it in kilowatt hour, and you might be using different appliances like bulb, like 5 bulbs, ceiling fan like 2, refrigerator. So how do you know the energy you consume in hours or in days or in 10 hours? Okay, so this concept actually help you to checkmate the things you use in your homes. All right, so this energy consumption is sold in kilowatt hour. So in this concept, we no longer check our times in minutes or seconds. Here, time is left in hour because you check it hourly, right? Okay. Then also, when I say kilowatt hour means that the power is left in kilowatts, no longer in hour. And I've already told you that if you want to convert from kilowatt to watt, you are going to do what? Multiply by 1000. But now, if power is given in watts and we expect it to be in kilowatts, what do? We are going to divide it by 1000 to be in what? In kilowatts. Okay, so I'm going to show you how we can use the illustration to solve this problem. And certainly a unit will be given, and 1 unit is what? In measured in kilowatts hour. Okay, so let's see how we can attempt problem on this question. Look for the cover. Cover. Marker cover. Hello. Thank you. Are you done? All right, just few seconds. Let me fill this marker so I can see clearly. All right. Let's look at what we have. The example 1 should be an electric lamp is rated 240 volts, 40 watts. What is the cost of running the lamp for 72 hours if the electricity authority charges 2 naira 50 kobo per kilowatt hour? All right, so going by what we have, the first thing we are going to do is for us to state the parameters given. They are giving the potential difference, that is V, to be 240 volts. They are giving the power to be 40 watts, right? So we have time. The time given is 72 hours. And the cost is 2 naira 50 kobo per kilowatt hour. That means 1 kilowatt hour. 1 kilowatt hour is 2 naira 50 kobo. Now the first thing we are going to do now is to get our power. After getting our power, then we get our electrical energy, right? Okay. Then we now equate it to this to see what we have. Now let's go. Our power, we're already giving power to the what? 40 watts, right? Now, I need this power to be in kilowatts. What do? I divide by 1,000. So I'll divide this by 1,000. This cancel this. So we have 0.04 kilowatts, right? Then don't forget the electrical energy is power times time. So E, which is energy, is what? Is PT. Now, what is my P? My P is here 0.04 kilowatts, right? And time is 72. I will say 72 hours. All right? So let's use our calculator to multiply. 0.04 multiplied by 72. So I'm going to have 2.88. It will now be kilowatt hour, right? So our energy obtained now is 2.88 kilowatt hour. Okay? Now, but from the question, they told us that 1 kilowatt hour is sold at 2 naira 50 kobo. And if you're able to generate this power, this is the power this is the energy we consume so far. We consume 2.88 kilowatt hour. Okay, so let's see how much it's going to cost us. We're going to say if 1 kilowatt hour is equals to 2 naira 50 kobo, therefore 2.88 kilowatt hour is going to give us what? S, right? They are simply going to say cross what? Multiply. That X is the cost that I'm looking for. So I'm just going to multiply 2.5 times 2. Okay? Let's work it out. 2.50 times 2.88. So what do I have? I have 7 naira 2 kobo. So what I have here is what? 7 naira 2 kobo. Now let me do a recap. We are given an electric lamp is rated 240 volts, 40 watts. What is the cost of running the lamp for 72 hours? If the electricity authority charges 2 naira 50 kobo per kilowatt hour. Now, if you have that, you have potential difference to be 240 volts, power to be 40 watts, and time to be 72 hours. And I told you that in this concept, our time is now in hours, right? We generate our time in hours, and we don't need to convert it to seconds. So what do? We just leave it at 72 hours, okay? But from the question, they gave us a cost. That 1 kilowatt hour costs 2 naira 50 kobo. So what do? The first step you're going to do is for us to find the power. And what is power? Power is 40 watts. Now we need to make the power to be in kilowatts. Simply by dividing by what? By 1,000. So we say 40 over 1,000. When we divide, we're going to have 0.04 kilowatts. Okay? Then electrical energy is power times time. Then my power is 0.04 kilowatts multiplied by time, which is 72 hours. By the time you multiply, you're going to get 2.88 kilowatt hour, right? But from the question, 1 kilowatt hour is 2 naira 50 kobo. Therefore, what will 2.88 kilowatt hour give us? That is the cost we're actually looking for. So I'm going to put it down and say cross multiply. By the time you multiply the two of them, you're going to have 7 naira and 2 what? Kobo. That is 7 naira 2 kobo. That is the cost of using this appliance. So let's look at another question. Okay, this will be example 2. All right, let's look at this second example. An electric heater takes 4 amperes operated on a 250-volt supply. What is the cost of the electricity consumed at 10 kobo per kilowatt hour when the heater is used for 5 hours? Now, going by this, we are going to see that in this particular question, that the heater uses a current of 4 amperes. So my current becomes 4 amperes, which is equals to 250 volts. Okay. Now, the electricity was consumed at 10 kobo per kilowatt hour. So that means per means 1 kilowatt R is equal to 10 kobo. Okay? Whereas time is given as 5 hours. The first thing we are going to do now is to find our power. That's find our electric power. After finding the electric power, we are going to find our electrical energy. Okay? Before you can equate it with the cost to find what you're looking for. All right? Now, what is my power? My power is what? IV. That is 4, which is current, times 250 volts. Now it's going to give me 4 times 250 is going to give me 1000 watts, right? Now this power, I need to convert it to kilowatts by dividing by 1000. If I divide by 1000, what do I have? This cancel this, this cancel this, this cancel this. It's going to give me 1 watt. Okay? Okay? It's going to give me, it's already a watt, it's going to give me 1 kilowatt. Kilowatt. Okay? Then for the energy, energy is equal to power times time. What is my power? My power is 1 kilowatt times what is my time? 5 hours. When you multiply energy, you're going to have 5 times, and you're going to have 5 kilowatt hour. Then from the question, 1 kilowatt hour is sold, that is a unit, is sold in at 10 kobo. I will say if 1 kilowatt hour is equal to 10 kobo, the cost is equal to 10 times what? 5. And the cost is going to give me 50 kobo. Is that okay? Let me do a recap. An electric heater takes 4 amperes when operated on a 250 volt supply. What is the cost of the electricity consumed at 10 kobo per kilowatt hour when the heater is used for 5 hours? Now, what do we do in this question? We already know that the current is given as 4 amperes. We have it here. Potential difference V is given as 250 volts. Now, we have that a unit, which is 1 kilowatt hour, is sold in this question at 10 kobo. Now, we are given time for 5 hours. So what we are going to do is to find our power. And our power is IV. Okay? Now, 4 times 250 give us 1000. Because I want to convert it to kilowatts, I'm going to divide by 1000 to give me 1 kilowatt, right? Then electrical energy, E, is PT. Okay? So what is P? 1 kilowatt multiplied by what is time? Time is 5 hours. By the time you multiply, you're going to have 5 kilowatt hour, right? Okay. But 1 kilowatt hour is equal to 10 kobo. Therefore, how much will this one give us? 5 kilowatt hour is equal to X. And that X is our cost. That is what we're looking for. You say cross multiply. So cost is equal to 10 times 5. And we got our answer to be 50 kobo. I hope you understand that. So let's see another question. All right, let's look at this question. What is the cost of running 550-watt lamp and 400 lamps for 10 hours? If electrical energy costs 2 kobo per kilowatt hour. Now, how do we solve this problem? You must not forget that this lamp that ran, this is 5 times how many? 50 watts. It's just like you have 5 lamps in your house, part of the appliances, okay? And each of them, the power that it can consume is 50 watts for one. So how do you know the total power consumed by those 5 lamps? And each of them can consume 50 watts. What do we do? It's just like saying 50 times how many? 5, okay? All right. So the first power we have how many lamps? We have 5. And each of them can consume what? 50 watts, okay? We are going to multiply 5 times 50 to give us what? 250 watts, right? Then the second one, we have 4, but each of them can consume 100 watts. So this is 4 times 100 watts. It's going to give me what? 400 watts. Now, what are we going to do? The total power is for us to say P1 plus what? P2. Let's add them together. That is 250 plus 400 is going to give us 650 watts, right? Now, the next thing is to convert this watts to kilowatts by dividing by 1000. P is equal to, okay, we have 650 over 1000. So we say 650 divided by 1000. We have 0.65 kilowatts. I've already explained why you're converting to kilowatts, because a unit costs 2 kobo, right? A unit is just a kilowatt hour. Now the energy consumed is power times time. What is my power? 0.65 times my time, which is 10 hours. I'm going to have 6.5 kilowatt hour, right? But from this question, 1 kilowatt hour is given as 2 kobo. 1 kilowatt hour is equal to 2 kobo. Therefore, 6.5 kilowatt hour is going to give us X, and that is what you're looking for. So we say cross multiply. The cost is equal to 6.5 times what? 2. That will give us 13 kobo. 6.5 times 2 will give us 13 kobo, or we can say that is equals to 0 naira 13 kobo. You see the same thing. 0 naira 13 kobo. I hope you understand. So let me do a recap. This question gave us 550 watts, okay, and 400 watts lamps for 10 hours. Now, what the first thing to do is we have 50 watts lamp, and they are 5. Just multiply it to know what all of them will give us for 10 hours. That is 250 watts, okay? So we have 100 watt lamp, red, and there are 4. Multiply it together to get 400. For us to get the total power consumed, we're going to add them together by saying 250 plus 400, which will give me 650 watts, okay? So I will divide it by 1000 just to convert it to kilowatts. So I will have 0.65 kilowatts. Energy is equal to power times time. That is 0.65 times 10. So what do we have? We have 6.5 kilowatts hour. But from the question, 1 unit, which is 1 kilowatt hour, is sold as 2 kobo. Therefore, 6.5 kilowatts hour is going to give us what? X. And that is the cost we are looking for. So we say cross multiply. We multiply 6.5 times 2, give us 13 kobo, or better still, 0 naira 13 kobo. Do you understand? All right. So let's look at another question. All right. So let's look at this fourth question or fourth example. A household refrigerator is rated 200 watts. If electricity costs 5 kobo per kilowatt hour, What is the cost of operating it for 20 days? Now, this question is different from what you just saw previously. Okay, so let's just set our parameters and I'll explain. Now, we have the power rated to be 200 watts. That is my P to be 200 watts. Okay, and the cost is 5 kobo. That means 1 kilowatt hour costs 5 kobo. What is the cost? We're looking for the cost of operating it for 20 days. That means my time is 20 days. All right. Now we know we normally solve it in hours. Now, how do we convert this day to hour? Okay. If you remember that 24 hours gives us 1 day. That means in 20 days, we're going to have what? We're simply going to multiply these 20 days by 24 hours, right? Okay. So we use our calculator by saying time is equals to 20 times 24 hours. So we have 480 hours. Now, let us find the power. The power is already given in watt, which is 200 watts. Then we convert this watt to kilowatts by dividing by 1000. Okay? So we have 2 divided by 10 to give me 0.2 kilowatts. What next? The next thing I'm going to do is to find our energy. Energy is power times time. Okay? What's my power? My power is 0.24 kilowatts times my time is 480 hours. Now let's multiply. 0.2 times 480 hours. I'm going to have 96 kilowatts hour. So my energy is equals to 96 kilowatts hour. Okay? But in this question, 1 kilowatt hour costs us 5 kobo. That is a unit. I will now say if 1 kilowatt hour is equals to 5 kobo, therefore 96 kilowatt hour is going to give me X. And that is the cost I'm looking for. Then I will say cross multiply. My cost is equals to 96 times what? 5. So I will say 96 times 5. What do I? I'm going to have the cost to be 480 kobo. That 100 kobo equals 1 naira. Okay? So what do we say? This is equals to 4 naira 80 kobo, because 100 naira is equals to 1 kobo, and we have 400 naira. Okay, so this is 480 kobo. That is something as 4 naira and 80 kobo. Do we understand? So let me do a recap. A household refrigerator is rated 200 watts. That is the power. If electricity costs 5 kobo per kilowatt hour, okay, that is the cost for using it for 1 unit. 1 unit costs 5 kobo. What is the cost of operating it for 20 days? Now, after setting our parameters, we should know that we're going to convert the days to hours. If in 24 hours, okay, makes 1 day, and we have 20 days. So how many hours are there in 20 days? Simply multiplying the 20 by 24 to have 480 hours, right? Now the power is given as 200 watts. Then I'm going to convert it to kilowatts by dividing by 1000. So we have 0.2 kilowatts. So the energy is power times time. That is 0.2 kilowatts times 480 hours. Then we have 960 kilowatt hour. Okay, then 1 kilowatt hour is equal to 5 kobo. Therefore 96 kilowatt hour is going to give us what? Then it gave us cross multiply, it gave us 480 kobo. Don't forget that 100 kobo is equal to 1 naira. So this is what I'm saying, 4 naira and 80 kobo. I hope you understand that. All right. Okay, so let's solve the last for today, which should be our example 5. All right, let's look at this last question for today. A man uses 560-watt bulb and a 240-volt water heater in his apartment. If the bulbs and the water heater are switched on for 4 hours daily and the cost of electricity is 1 naira 20 kobo per kilowatt hour. Now, the first we are going to do is to state our parameters. We have the first power given, we have 5 multiplied by 60 watts bulb. We have 60 watts. So you're going to give us 300 watts and also a water heater rated 240 watts. 240 watts. Now for us to get the total, we're going to say P1 plus P2, that's 100 plus 240. So the total power is going to give me what? 540 watts, right? Okay. Then this man is using these appliances for 4 hours daily. Okay? And in every how many days? In 30 days. Well, how do we solve this problem? What you're going to do, you're going to convert these days to hours. I told you that 24 hours is equals to 1 day. Now, you're going to say time is 30 days times 24 hours, right? So let's see what we have. We are going to have 72 hours. Now, this is just for 30 days, but each day he earns it for 4 hours. So we are going to say again, our time, we are going to multiply by 4 hours. That is 4 times 72 hours. We have 228 what? Hours. Okay? All right. Now, you should not forget that a cost, that is 1 kilowatt hour is 1 naira 20 kobo. But then, let's get our energy. Our energy is P what? PT. Okay? So what's my P? There's something we missed. Okay, let's convert this our power to kilowatts. So P is equals to 540 over 1000. Okay, let's convert to kilowatts. 540 divided by 1000 is equals to 0.54 watts. Kilowatts. 0.54 kilowatts. Okay. All right. Let's get our energy. Energy is PT. That is 0.54 times 2,880 hours. So my energy is equal to 0.54 times 2880. So I'm going to have my energy to be 1555.2 kilowatt hour. But from the question, 1 kilowatt hour is giving us 1 naira 20 kobo. Therefore, 155.2 kilowatt hour is going to give me X. And that is my cost. So I will say cross what? Multiply. Okay? So if I say cross multiply, my cost is going to be what? It's going to be 1866.24, right? But knowing that, okay, so we have that. So that is what we have. I don't know if you have any question. Okay, let me go again. Okay. Okay, there is a mix-up, so I'm going to resolve from here down. All right, I'm going to resolve from here down. Now, if I convert this to kilowatts, I'm going to divide by 100, 1000. So to get 540 divided by 1, then I have 0.54 kilowatts, right? Okay. Then the time. Previously, I solved for time. I said 30 times 24 hours. But this man used it for only 2 hours out of the 24 hours. So we are not supposed to multiply by the whole 24 hours because he did not use it the whole of the 24 hours, okay? He used it with just 4 hours. So for us to get the time, total time, I'm going to say he used it 30 days, but each of the day is what? 4 hours. So you're going to multiply by 4 alone. So we say 30 times 4. I'm going to have 120 hours, okay? So now let's get the energy. The energy is what? PT. Now what is my power? My power is 0.54 times 120. Okay? So let's go. 0.54 times 120. I have 64.8 kilowatts hour. Okay? But from the question, 1 kilowatt hour. 1 kilowatt hour is equals to 1 naira 20 kobo. Therefore, 64.8 kilowatt hour. 64.8 kilowatt hour is going to give us X. And that is the cost we are looking for. So we say cross what? Multiply. So I'm going to say the cost is equal to 64.8 times 1.2. So let's work it out. So my cost is equal to 77.76. That is 77 naira 76 kobo. So this man's bill for 30 days is 77 naira 76 kobo. Now let's do a recap. A man uses 560 watts and a 240 watt water heater in his apartment. If the bulb and the water heater are switched on for 4 hours daily and the cost of electricity is 1 naira 20 kobo per kilowatt hour, calculate his bills for 30 days. All right, so what we need to do here is to get our total power. This is, he's using 5 different lamps and each of them rated 60 watts. So I'm going to say, to know the total watt consumed, I'm going to say 5 times 60 watts to give me 300 watts. Okay? Then his water heater rated 240 volts. 240 watts, sorry. So how do you get the total power? We're going to say P1 plus P2. When we add, the total power becomes 540 watts. Now to convert this power to kilowatts, we divide by 1000 and we have 0.54 kilowatts. Okay, coming to the time, he used these appliances for just 30 days, but he did not use it for the whole 24 hours. So initially I multiplied by 24 hours and I found out that it's wrong, so I have to correct it. Okay, Now, since you use it for only 4 hours, what you're going to do is just to multiply this 4 by the 30 days, okay? So you say 30 times 4 to give me 120 hours. For me to get the energy is power times time. So I'm going to say 0.54 times 120. So what do I have? I have energy to be 64.8 kilowatt hour. Okay? But from the question, 1 kilowatt hour is equal to 1 naira 20 kobo. Therefore, 64.8 kilowatt hour is going to give us X. And that is what we are looking for. It's a cross multiply. So the cost is equal to 64.8 times 1.2. And I'm having 77.6, right? And my answer becomes 77 naira 76 kobo. So this is the man's bill for 30 days. I hope you understand this clearly now. All right, we have come to the end of today's class. So if you have any question, if you have any topic you want me to teach you, you can drop in my comment section. And see you next time. And please don't forget to subscribe to this channel for more educative videos. See you next time in my next class. Bye.